Natural selection is one of the presentations that we offer. CSI is a national distributor of various stone lines, both natural and manufactured, across all of North America. And today we're going to focus specifically on natural stone.
Sorry, folks. Looks like we lost audio there for a second. If you can just hang tight, we'll get Nathan back on the line here in 1 second.
Sorry, guys. Somehow or the other, it muted me. So just to review the learning objectives for this presentation are the history and benefits of natural thin stone veneer. We're going to compare different stone types and analyse their suitable applications. We're going to analyse some wall assemblies to which natural stone veneer can be attached, and look at some pitfalls and how to avoid them. And we're going to establish some best practices and systems. We'll talk about rainscreen for the selection and specification of wall assemblies incorporating natural thin stone veneer. So, natural stone 101. There are basically 3 types of natural stone that occur: sedimentary, metamorphic, and igneous. Sedimentary rock is rock that's formed through the deposition and solidification of sediment, predominantly sediment transported by water through rivers, lakes, oceans, glaciers, that kind of thing, and also wind. And basically, it's formed when the Earth is subjected to a lot of pressure, and all the Earth forms into a rock formation known as sedimentary rock. This is the type of rock that you'll often see striations or layers in, and it frequently can contain some pretty interesting fossilized flora, fauna, and small sea creatures, that kind of thing. The 2 most typical sedimentary rocks that we see in construction are limestone and sandstone. Metamorphic rock is, as the name suggests, a rock that is formed in one way and then metamorphosizes into a rock with different characteristics than it originally had. And that change is brought about by intense heat and pressure that causes physical and chemical changes in the makeup of the stone. These rocks can vary wildly in terms of their density. They can be incredibly hard at one end of the spectrum and very, very soft at the other. And examples of metamorphic rock that we see, again, in the construction side of things are very, very frequently are schists and quartz. The third group of rock is igneous rock, and this is basically formed from magma or lava in the earth. As it rises through the earth's crust, it cools, and in that cooling process forms itself into what we refer to as igneous rocks. These are typically the hardest stones that we build with, and examples of igneous are granites and basalts. So having discussed the types of rock that we have, and let's move on to the quarrying and fabrication process a little bit. Quarrying's changed quite a bit over time. It's become a much more efficient, more effective, and more environmentally sensitive process than it used to be. We've come a long way from when the stone was literally blasted out of the quarry, because not only was that dangerous and environmentally a little irresponsible, it led to extremely high waste. It damaged the integrity of the stone, which would cause problems further down the fabrication process. And so they came up with multiple gentler ways to extract the rock. You'll be able to see in that picture on the top left-hand corner, you'll see the core marks down the side of that rock. That piece of rock was extracted using a kind of modern-day alternative to what they used to call plug and feather, when they drill a small hole and tap a tapered plug into it and push feathers down the side of it to expand and cause a crack in the stone. They do that more recently with a chemical compound, which is, the stone is drilled, the compound is poured into the drill hole. The drills are at various centers across along the stone, and then as that material dries, it expands and causes a uniform crack along the quarry, and then those pieces are taken out from there. And more modernly now, you're seeing a lot of diamond saws, diamond chains used to cut the stone straight out of the quarry. It leads to obviously better quality stone. It leads to less fissures and problems that become apparent again further down the process, and it's just altogether a more efficient way of doing things. The block on the right, top right, is the same block as the one on the top left. That's after it's been dressed. So one of the first things they do when they get the raw blocks out is then dress them, even them up, and at that point they decide what we're going to do with this particular block of stone. So it may be cut into slabs if it's determined that that's the best use for it. It may be broken down into 3 to 5 inch full bed stone, and then that full bed stone, some of that may well be taken and put through the saws that you see in the bottom left-hand corner there to produce what we refer to as thin veneer in both flats and corners. And you'll see there what the resultant flats and corners look like. The corner is critical, as it is with any thin veneer in masonry, to create that illusion of full bed material that you're trying to achieve. Without a 90-degree return, it really does just look like a flat piece of stone bonded to a wall. But with the use of the corners at 90 degrees, it creates that full bed illusion that we are all looking for. So why use thin veneer? What are the advantages? Well, weight, speed of installation, application versatility, cost and ease of installation. Natural thin stone veneer typically weighs obviously less than full bed stone, and therefore it offers a greater design flexibility and a wider possibilities as far as applications are concerned. It typically installs much faster than full bed masonry, which makes for a more productive site and can impact the bottom line. And it typically has a cost advantage over its full bed counterpart. And in some cases, you can find that natural thin veneer now is only marginally more expensive than manufactured stone. And finally, it's a much easier install process than full bed structural stone, and that can open the bid process up to a wider audience of contractors, and again, that too can have a positive impact on the budget for a project. So now we'll look at some of the influencing factors when you're selecting stone. Obviously, with stone, as with many other masonry products, aesthetics is a key driving factor. You want something that has the right texture to it, the right color, and the right overall appearance. However, there are times when that's not necessarily going to be the biggest factor. In some applications, you know, strength and durability of the stone may trump the aesthetics. And what I mean by that is that you may find a stone that looks the way you and the client want the project to look, but on deeper investigation, you may find that particular stone color finish is not really a possibility in terms of gaining the strength and the durability that the project requires. So sometimes there does have to be some compromise that's reached on that. So textures, some stones take different texturing processes well and better than others. You're also going to take into account size. There's been a move more recently in a lot of markets towards larger format stones. Well, sometimes in order to get that size of format, you may find that particular stone that passes the aesthetic test actually ends up being too thick to be considered a thin veneer, and the only way you're going to get that is to move to full bed, which is obviously going to impact the design and the costs. You're going to want to look at stone testing and sampling, all of which, all of those things all tie into the cost and the budget for the project. So other influencing factors are projects. It's always a good idea to see a project already completed in the stone under consideration, if at all possible. One of the biggest challenges for any supplier of natural stone is the sampling process. Because of the natural variations that occur in the stone, it's very difficult to always show that full range. So the more stone you can see before finalizing this decision, the better. It's going to mean that the client has more realistic expectations, and those expectations are easier for everybody else in the chain to manage and meet. Obviously, natural stone isn't manufactured in any way, but there is typically some fabrication involved. And as with any facility that fabricates, there's going to be capacity constraints. So particularly with bigger projects, you know, it's wise to ask some questions about the capacity and about the distribution of that particular stone. We often find ourselves in situations in Canada where products are specified that are either coming from you know, way out east or from other parts of North America, and they're just not readily available in the area where the project's taking place, and that can cause some problems again. So asking some questions around that is always useful as well. And then technical support, installation guidelines, sales representation that can help with local codes if you're working on a project that's outside of your typical jurisdiction, wall assembly understandings, and a stone from a source that has access to detailed drawings for you, can advise you on things like rainscreen and exterior insulation. They're all useful things to have access to as and when you need them. More influencing factors. People often forget that, especially on larger projects, you know, natural stone veneer is just that, it's natural. And as such, it can change over time. You know, on a bigger project that may be phased, it's good to look back at how long that quarry's been in existence and what their consistency has been like. Because stone out of that quarry 6-12 months from the day at which you start the project may be different. Also, you may have multiple quarries in the same Sorry about that. I don't know why that's doing that. There may be multiple quarries in the same region, operated by different companies, and their processes are different, which can mean that the finished product, although it's the same stone type, can have some different appearances, and it can vary from quarry to quarry. And then also be careful when you're mixing stones. Sometimes you can't find the exact stone that you want, but a blend of 2 or 3 stones will give you the look that you're striving for. Just be aware when you're mixing stones with different physical properties, that they're going to wear in a consistent fashion. They're going to weather in a similar fashion, so that one stone doesn't start to look significantly different to the others over time. One of the things we mentioned earlier was finishes. There is an ocean, it seems at times, of different finishes that you can apply to natural stone. I'm just going to talk about ones that are typically seen from an exterior perspective. When you get into interior finishes, you have many more options that are suitable for interior. But on the exterior finishes, traditionally we see the natural weathered face, which is pretty much the way the stone comes out of the quarry almost. You'll see hand-hewn or rock-faced finishes, where stonemason actually manipulates the face of the stone. And tumbling is another one where stone and sand are added into a tumbler, which is somewhat akin to a large cement mixer. It rotates and it gives the stone a softer, more weathered appearance right from the get-go. And then on the contemporary side, you've got honed, which is kind of a semi-polished, smooth finish. Polished, which obviously, as it suggests, is a very glossy finish. And then saw cut and textured. A lot of times you'll see products sawn, and then that sawn face can be textured in a whole plethora of different finishes, from sandblasting or shot blasting. It can be bush hammered, it can be flamed or thermally finished. There's a number of different options that you can get that give a more contemporary look. Some attention should also be given to the cut of the stone. Interesting thing is that the way you actually cut a stone can affect its performance and its characteristics. There are 2 main cuts: the flurry cut versus the vein cut. So obviously don't know where you guys are listening to this, but whichever room you're in, if you think of the walls in terms of the wall of the quarry, that would be the vein cut. So you would look at and see the striations and the layers of the stone built up. And the floor of the room you're in would be what we would refer to as the flurry cut, or also known as the bed face. So you can see that little picture on the side of that slide. You can see all those striations on there. That's an example of a vein cut. If you were to imagine slicing straight into one of those veins and turning it through 90 degrees, that would expose the bed face or the flurry cut. Typically, the color tends to be a bit bolder on the flurry cut, and whereas the vein cut of the same stone can often be a little more muted in appearance. And sometimes that vein and flurry cut can be very different. And again, keep in mind when it comes to that 90-degree corner, in some stones you may get the flurry and the vein on the same corner. If those are drastically different, then extra attention has to be paid to how you're going to treat those corners to avoid having sort of a zip fastener effect up the side of the building. Testing. This is a funny one. If you'd asked anybody involved in natural stone a few years ago about testing, likely would have smiled at you. But because manufactured stone has become such a huge part of the stone industry, it's kind of set people's expectations. And so the architecture and design community, when they specify manufactured stone, have become attuned to asking for test data as a guide and an insight into likely performance of the product. And some of that's trickled back into the natural stone side of things. And so we are finding that we're getting asked more and more for test data on natural stone, which makes sense. And the ASTM organization do have a full suite of tests for natural stone that set a standard and a global bar for different stone types. The one thing to remember with test data, just like with literature, product literature, it can be out of date after a period of time. As people go through, as a quarry works through itself, it is the right thing to do to have those tests redone at regular intervals, because obviously not only can the appearance of the stone in a quarry change, but also its physical characteristics can alter from time to time as well. So you are absolutely within your rights as specifiers to ask for test data that is up to date and current. And the sort of things that we're testing for often have a lot to do with the strength perspective of the stone. You want to know what it's going to, how it's going to react to wind loads, gravity loads, elastic distortion, freeze-thaw cycles, and what the absorption and porosity of the stone is. Anything that will, potentially affect the durability and the life of the stone, as well as the appearance. So there are many other tests than these, but these are kind of the core ones. They're obviously compressive strength, as I said, flexural strength, the modulus of elasticity, and shear bond strength. The shear bond strength also speaks to mortar, obviously, but it's an important one. And if you're designing a project in an area where weather is a factor, you're also going to want to look closely at the water absorption of the product, the porosity and the permeability of the stone, and how it reacts to freeze-thaw cycles. So from there, we're going to move on to look at a couple of different wall assembly situations. These are some standard details that we offer. The one on the left is just a straightforward wood frame. So your sheathing, weather-resistant barrier, expanded metal lath, mortar scratch coat, mortar setting bed, and the stone. Similarly, on the right, it's pretty much the same detail, but with the introduction of the minimum 10mm drainage plane that's required in some jurisdictions in Canada. I don't know that it's necessarily become code in any parts of the US yet, but I do know that several states in the US and several parts of the US are designing with rainscreen in mind, because water management has become such a big issue everywhere these days. There's a shameless plug for Keen's drywall rainscreen drainage mat, which we recommend. We recommend a drainage mat over and above timber strapping. It's in all the independent tests that have been done. It shows better drying time and more efficient shedding of moisture. And also, just on a logical level, the using a material like wood to create a cavity that has to stay dry and drain rapidly seems counterintuitive, because wood by its very nature needs to hold and absorb moisture. But we are seeing more and more rainscreen everywhere now, because it deals with any moisture that gets into the building, rather than trying desperately to defend against it coming in. I mean, we still design to try and avoid more moisture penetration, but also acknowledge that if it gets in, it does need to be managed. Cement board applications. We'll talk a little bit about this because there's been some changes in this recently, and also we'll touch on some mortars here. In the thin veneer market, we had a bit of a battle for a number of years, because a lot of the cement board manufacturers were saying that manufactured and natural thin stone veneer could be applied directly to cement board. And while that may or may not have actually worked in the field, it wasn't necessarily correct from our perspective, because no testing had been done with it. That situation's changed now, and provided that the cement board meets ASTM C1325, and for exterior applications, provided that the joints of the board are taped, it is now permissible to go directly onto a cement board, provided you use a polymer modified mortar. So anything that meets the standard in the column at the far right of that table is good to go. And similarly on interior applications, the only difference there is, while it's still good practice to tape the boards, it's not entirely necessary on an interior application. So let's talk about concrete wall assembly and tilt-up panels, poured in place, that kind of thing. With CMUs, like you've got in the detail on the screen now, you can apply thin natural stone veneer directly to that, provided the surface is clean, clear of paint, oil, grease, or anything else that will inhibit the bond. And if that is the case, then you can apply the stone directly to it, just using a set-in bed, and off you go. When it comes to tilt-up panels or poured-in-place concrete walls, the same applies, but there is a bit of a caveat with that, because typically those poured-in-place and tilt-up panels have been formed using concrete forms with a form release agent. So it is critical that that form release agent is removed. And what we found over the years is that that's a function that seems to fall between two stools. What I mean by that is that oftentimes the masonry contractor will assume that the general contractor has cleaned it prior to his arrival on site. The general contractor in turn will assume that the masonry contractor will take care of that once he gets to site. And what happens often is nobody takes care of it. In our experience, if you have a poured in place or tilt-up panel wall and the issue of form release agent is not dealt with, it is not a question of if your stone falls off, it's a question of when it falls off. In order to clean it, there's a couple of different options. You can sandblast it, which is kind of noisy and messy. You can use muriatic acid to clean it off, and then make sure that you clean the muriatic acid off. That's a pretty aggressive product, and a lot of contractors don't like having that on site. But both of those work very effectively, and then the stone can be applied directly to the concrete wall. Some masons will put a little bit of a thin set additive into the mortar mix, something like a Bondex or Fab Weld or something like that, in order just to give it a little bit extra adhesion. There is a third option, and in my personal opinion, it's the best option, and that is don't clean it off at all. Contact Hilti or one of the fastener companies, get a fixing pattern for a weight not exceeding or not less than 25 pounds per square foot. Get a fixing pattern for that, and actually shoot lath onto the wall. Now, you can only do this with poured in place or a tilt-up panel. They don't recommend that you shoot fasteners into CMU walls, but that provides a mechanical fastening for the stone, and it completely alleviates any concern whatsoever about form release agent and what it may or may not do to the bond down the road. Okay, so moving on, let's look at some common mistakes that we see with installation. We often see flashings either improperly installed or missing. We frequently see stone going too close down to grade or to the ground. Color banding that can exist. Improper setting bed. You can see an example in the first picture on the right there of the, you see the shadowing behind that stone. The stone should be, the entire surface area of the back of the stone should be covered in mortar, and then it should be pushed onto the wall with sufficient force to cause that mortar to ooze around it, allowing the mason to scrape off any excess. You'll often hear masons talk about creating a vacuum. So they'll put like a ring or a donut of mortar around the edge of the stone, leave a void in the middle, push that onto the wall, and they'll claim that that creates a vacuum that sucks the stone back to the wall. There's zero evidence to suggest that that's even likely, let alone a fact. In fact, what it does do is create a void behind the stone where moisture can accumulate, and then you can get into a freeze-thaw situation, and obviously you can see that stone pop off the wall because of that. We often see mortar color consistency issues, inconsistent mortar jointing, and uneven installation and stone distribution. And sometimes improper lath installation. You see, whenever you see cracking, like you see on the picture on the far right there, typically if you see that on a job site that you go to, and it's roughly at every point where the edge of a piece of lath would be, that's a pretty strong indication that they have not overlapped the lath correctly. And why that's important is if you get cracking in the scratch coat like that, there's a very good chance that you will get cracking in the stone as well. That can transfer through. So how do we avoid those common mistakes? Well, it's all about, as I mentioned earlier, setting expectations and then finding a way to manage and meet those. The picture on the left is a picture of the Banff Springs Hotel in Banff, Alberta, and it's a stunningly beautiful hotel. If you've never been there and you ever get the opportunity, I strongly recommend you do. It's worth the price of a night there just to be able to walk around the hotel and just take it all in. And it's built predominantly from a stone that occurs naturally just south of Banff in Canmore, called Black Rundle. But occasionally, Black Rundle is more brown than black, and occasionally, sometimes that's the Black Rundle that goes on the wall as black will turn brown over time. I don't know if you can see it on your screens, but there's a buttress there where it's clearly more brown than black, and there's nothing wrong with that. It's one of the characteristics of that particular stone. However, had you as the architects or the client been shown the sample on the right and then seen the brown on the building, I imagine that would have come as quite a shock to you. So again, to a point we made earlier about sampling, you can never sample enough when it comes to natural stone. Had there been some brown in there and an explanation supporting why it was there, I'm sure the same decision would have been made to run with the stone. But everybody would have known what was likely. So how do we avoid these pitfalls and meet the expectations and manage the expectations? Well, the best way we know of is a good strong mock-up panel. You see there's a picture there. it's fair to assume that was not the desired look that the client or the architect had in mind. And had they put together a mock-up panel and insisted on a mock-up panel being built on site, that could have been avoided. Mock-up panels should typically consist of the stone, obviously flats and corners, any accessory items such as sills, lintels, etc. At least one transition into a dissimilar material where the stone meets stucco, siding, whatever. And then once complete, that panel can be used to determine the acceptable width and consistency of mortar jointing, acceptable mortar color, the stone distribution that's required for that particular type of stone, the spread of sizes and shapes, the consistency of the stone that's going to be supplied, and an overall standard of installation. And then once everybody's agreed on their particular part of that mock-up panel and everybody's happy, the project proceeds. And if there's any issues down the road, then you go back to the mock-up panel, find out where it differs, who's responsible for that, and that's where the responsibility lies to rectify it. It's not always possible to have a freestanding mock-up panel on site. So oftentimes a small portion of the building can actually be designated as the mock-up panel, and the key there is just to remember which particular area it was. So just to review, avoid selecting stones purely on the basis of their appearance. The aesthetics obviously play an important role in the selection, but oftentimes there are other factors at play that may mean that stone that looks perfect isn't. You have a lot more flexibility on the interior application, on an interior application for the stone that you use, where there are no environmental factors to consider, and set and manage expectations throughout the sampling process using mock-up panels, and you will typically that will typically result in a very satisfactory finished project for all that are involved. So thank you for taking the time this morning to listen in. I hope you found that instructive and of some benefit. And if there's any questions, I guess the lads will jump in there and let me know.